Okay, so this week in week 5, we cover a session called Statistics Without the Stress. And it's really aimed at those of you who are doing non-review based dissertations. So those of you who are doing systematic reviews and critical reviews will obviously get benefit from it, because when you're assessing the quality of the literature that you use, then this session comes in handy when comparing the robustness and the quality of the literature. Really handy, because it's very important to have a good understanding of what the appropriate statistical tests are and which ones are those that give the most robust, results. However, what we'll do this week is I'd also like you to tune into this lecture online, and because what I've noticed is very, very apparent is quite a few students haven't managed to do their ethics yet. That's crucial. And quite a few of you, those of you who have data from your supervisor, appear to be still a little unclear as to exactly how you're using it and what you're doing with it. So with that in mind, I'd like you to use the time this week to contact your supervisor, do anything that you need to do, and indeed contact me. So obviously the time where we would have the lectures, that's time that is available to speak to me, talk to me, anything at all, to make sure that you're moving forwards at the right pace to have your first draft ready for the Easter break just before then, and you'll be on the right track. Okay, so without further ado, today's lecture, Statistics Without the Stress. So some statistics without the stress, hopefully. So another statistics lecture? Well, not really. The focus of this session is on getting each stage of the statistical process right. So we're not going to drill down into great detail of what each statistical test shows, and the kind of underpinning theory behind it. You've done that before in other modules, plus I believe in this module also. So this session is going to be more focused on 3 main areas. Firstly, how you already think statistically. Then, where statistics came from. We didn't always have them. And then the third and final part of the session, the main part of the session, a guide to statistics minus all of the underpinning theory, and so without statistics, how do we make sense of the world, or just generally, how do we make sense of the world as humans? We do think statistically on many levels. So an excellent book, a bit of a dense read by Nobel Prize winner Daniel Kahneman. It's called Thinking Fast and Slow. But what he basically describes are things called heuristics. Now, heuristics are things that we ourselves have experienced about the world that allow us to make decisions moving forward and to make sense of the world moving forward. Now, sometimes, or most of the time rather, these are essential. Sometimes, when we rely too much on these things called heuristics, we can think and commit things called logical fallacies or certain what we call cognitive biases. So when we think about a bias, it tends to be a slightly skewed way of seeing the world. So just some examples here. We've got something called confirmation bias. We all tend to do this at least a little. So this is where we tend to accept information that reinforces our own worldview, and reject information that doesn't. So if a really kind of light-hearted example might be if you're into football, if you're a football fan, and I happen not to be, but if you are, then anything that kind of reinforces that your favourite team is good, a talented group of individuals, then we might be more susceptible to taking more notice of that kind of information. Other things like the gambler's fallacy. So an example of this would be if I was to ask you if that I have a coin, and if I flip the coin and it lands on heads, and then again I flick the coin and it lands on heads again, and I continue to do that, and it lands on heads 10 times. Then on the 11th flip, what do you think it would be, heads or tails? Do you think that, well, surely it's been heads for so long, tails is due sometime? Well, we'll see. There are other things. One's called the halo effect. This is where we it covers kind of a widespread area, really. People who tend to be more charismatic and more confident, and also better looking, the research shows, tend to be believed better and treated better by society. And I've got to, as I was watching the video that I'll show you, towards the end, I found it quite surprising myself, even. So yeah, I'll give you a watch of that. And social desirability bias, I'll explain after the video. So have a little look at this.
Confirmation bias. We tend to listen to information that confirms what we already know, or even interpret the information that we receive in a way that confirms the current information that we already have. Let's say that your friend believes that sweets are unhealthy. This is generally a pretty broad belief. He will only focus on the information that confirms what we already know. He is more likely to click on videos that confirm that belief, or read articles that support his argument. He doesn't go through and type, positive health effects of increasing blood glucose levels, or positive effects of eating a bowl of ice cream. No, he will instinctively go to Google and type in, how bad is sugar for you? The confirmation bias is very dangerous in scientific situations, and is actually one of the most widely committed cognitive biases. Number 6, the ostrich bias. This is the decision, or rather subconscious decision, to ignore the negative information. It may also be an indication we only want to consider the positive aspects of something. This goes beyond not only looking for the positive information, but this is when there is negative information and we choose to ignore it as an outlier. Sometimes, even when we have a problem, we try to ignore it thinking it will go away. Let's say you have an assignment to do. It's not something that you really want to do, so you may just keep on procrastinating with it, because your mind thinks that it'll go away, or is solved by ignoring it. Smokers usually, they know it's bad for their health, but a lot of them keep ignoring the negative implications of cigarettes, thinking it will not damage them or might stop them before anything serious will happen, because they consider themselves an outlier. To avoid finding out negative information, we just stop looking for it. Now, this could be a serious crime in many scientific research laboratories, and basically promotes ignorance.
You've watched that coin flip 9 times. Heads, tails, then heads again, then tails, 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 and what's going to come up next? Tails has been having a pretty good run, so it must be another tails. Or are we due for another heads? There are patterns everywhere in the universe, and our brain is very good at recognising them. Perhaps too good. It can readily see patterns that just aren't there. In truth, there is a 50% chance of heads and a 50% chance of tails after every toss. It doesn't matter what came before, and luck doesn't come into it. At all. But it's hard to shake that feeling that there's a pattern in there somewhere, if only we look hard enough. This is called the gambler's fallacy, our assumption that probability changes depending on past results. And this may explain why casinos make so much money. It's all a matter of probability, one of the more complicated forms of logic. In fact, it's so complicated that it was only a few centuries ago that some smart French chaps by the names of Pascal and de Fermat worked out much of the mathematics behind it. Our brains make it difficult for us to see the logic and probability and lead us astray. We're wired to link the things we see as if they're related. For example, seeing a flash of lightning and hearing a boom of thunder makes it seem as if the thunder was caused by the lightning. And there are plenty of reasons to believe that's true. But what if you ate a hot dog and then got sick? Was it the hot dog, or was it something else entirely? Medicine is full of such head-scratching questions. People take pills and feel better. But a lot of logic and probability is needed to determine whether the pills were truly responsible. Just because one thing follows another, even if it happens a few times, does not necessarily mean that they're linked. There could be other factors, or it could simply be coincidence. To know for sure, you have to test the circumstances again and again, looking for those other factors that could disprove the link. This reinforces confidence that your pattern is true. This is what science does. So while our brains see patterns, and this is often very useful, it takes science to prove that these patterns are real.
The impression you create is affected by the way you look. We tend to think beautiful people are more intelligent, popular, confident, and better at everything from their jobs to flying a plane. And if you can create a favourable impression, you can create advantages for yourself. You're more likely to get what you want. It might be a job, it might be popularity, or it might be the control you have over the people around you. Meet Ruth and Rebecca. Rebecca's classically attractive. Ruth's more on the plain side. They're going to demonstrate that how you look affects how you're treated. They're going to struggle up staircases at opposite ends of Liverpool Street Station in London with heavy bags, and we'll be filming in this workman's hut. First up, Ruth. How long before a knight in shining armour rescues this damsel in distress?
Oh, that's so kind of you.
Helped at last, but by 2 women, and it took 45 seconds. Now Rebecca's turn. How long before she's rescued?
Would you mind? Just shattered. I'm just trying to get to the top of those stairs there. Can you do the other one at the same time?
All of 8 seconds.
Oh, this is very kind of you.
Ruth is occasionally saved, but it takes longer. On average, 70 seconds.
Turned up.
Rebecca's average, 24 seconds.
Just stop by these phones here would be great. Thanks.
You'd be forgiven for thinking that this caveman behaviour is more about sex than chivalry.
Yeah, pretty girl, needing bags carrying upstairs. I'm a sucker for that sort of thing. Every time. From my grandfather, I'm told. He was a charmer too.
But there's more to it than that.
Thanks.
We have a tendency to think highly of beautiful
And just
people.
because they are very, very delicate. Sorry.
What's in them?
Family heirlooms, would you believe? Bringing them back from my mum.
And we want to be near them, as if some of their glory will reflect onto us.
Have you got a few minutes to spare? Because if he doesn't turn up, I'd need to get them into a taxi up there. I'm going to be really rude now and ask one more favour. Could you lend me some money?
How much you need?
Can you do them all three?
The men are mesmerised. They do anything Rebecca
Oh,
asks,
you're so strong. Thank you so much.
although they clearly go out of their way for a pretty girl.
You're a true gentleman. I really appreciate this.
They deny that looks have anything to do with it.
And I'm really thirsty and I wouldn't mind getting a drink and something to eat.
Oh, well, that's all I've got me at the moment. You're more than welcome to it, though. If somebody needed help, I'd like to think that I would help everybody across the range, regardless if they're good-looking, attractive, smelly, well-presented, or whatever.
An American study found business graduates earn $600 a year more for every extra inch of height. And in US presidential elections, the taller man has won 17 out of 21 times. So, to test whether size really does matter, we took two actors to the streets of New York. Marcus and Melvin are almost identical. Same age, similar looks, just one obvious difference. Marcus is 6'4", and Melvin's 5'2". But who looks more successful at work? First, tall man Marcus.
He's a lawyer, doctor, and then accountant.
I would say he's an executive who likes sports.
Probably earns maybe about $500,000 a year.
54, 58, close to 60 a year, 60,000.
I would say maybe 100,000 a year.
He looks like a tycoon.
Now short man Melvin.
He's little. Maybe a cook. It's like a cook.
I think he's a quiet guy, and he's not very happy. I think he's having a difficult situation right now.
So he earns about an average income, nothing fancy, but enough to live on, yeah.
Minimum wage, I guess, 20,000 a year.
On average, they credited Melvin with a meager $20,000 income and Marcus with a whopping $220,000. All thanks to a difference of 14 inches.
I wish I was his size, to tell you the truth.
So we saw an example of confirmation bias there. The sugar thing, yeah, sugar's not really good for you, but sugar is glucose and it's the body's preferred source of energy, and it's certainly to have kind of sugary snacks available for someone like a diabetic is life-saving. So yeah, two sides to the coin. Gender bias, again, doesn't have to be an unhealthy way of looking at the genders. The halo effect we saw in its extreme there. Social desirability bias is, I've seen this quite often in my research. This is where if I was to give a group of people a physical activity questionnaire to fill out, they would, because physical activity is a socially desirable behaviour, people tend to over-report how much they do. In contrast, if I was to give a group of people, or the same group of people, a dietary questionnaire, and let's say over 7 days ask them to record what they ate, then chances are that there would be a tendency of the respondents to underreport how much they'd ate. So on one of the or two of the days they might miss out one of those desserts that they had, or replace it with an apple or something like that. That's quite a common phenomenon, and that's why we if we're measuring physical activity levels, it's why we tend to prefer activity monitors. So how we make sense of the world, we do it by thinking statistically. So the better we can understand the world around us and be aware of how we think about it, be aware of these heuristic rules that we use, and that they're okay, but take care not to fall short of these cognitive biases that we saw in the video. And try and think statistically, because to think statistically is to think more with an open mind, more neutrally, and base our decisions on evidence or lack thereof. The better we can understand the world around us, the more control we have over it, or the more we feel in control. More of an internal locus of control, if you remember that from psychology. The more likely it is, if we're like that, we achieve our ambitions, because the more confident we're going to be, and we're going to be more likely to go for it. And as a result of that, the greater our sense of happiness and fulfillment. So I can, on a personal level, I can vouch for this, that we try and view the world without any bias, and really take a step back and remove all of your personal kind of experiences. Take a really neutral view of the world. It really takes the sting out of a lot of situations where we might previously have thought, ooh, that feels a little bit personal, or many times things can just be a misunderstanding. So an example is that, you might start a business, and let's say this business sells, you sell flip-flops. Don't know why I thought of flip-flops. Not the best business to start in Newcastle, but that's obviously you would be based online, if you had any decent business sense, and post around the world. Maybe you built up a good brand, and on certain years you noticed that business was very good compared to other years. Why is that? Well, how do we find out? What makes business better in those years? Well, you would identify all of the factors that affect sales. They would be your variables, and you would try and quantify them. So if one factor that affected sales was the duration of the hot weather in summer, it's got to be a factor that affects flip-flop sales. And then think of a load of other variables. And then you can use statistics to look for patterns and trends and relationships between variables and the main outcome measure of interest, which is sales, to make a profit. And any decent business does do this, actually. And the bigger businesses have whole departments of statisticians that look at these kinds of things. In doing that, you might identify that it's marketing on YouTube that significantly increased sales. You might have trialed it in year 3 that the business was running, and then tried it again in year 5, and it might be those 2 years that you made huge increases in sales, and therefore you might choose to plough a lot more funding into marketing on YouTube. So there's an example of how statistics has helped you succeed, make better sense of the world, and a greater sense of happiness and fulfillment. So we tend to use statistics blended with our own human experiences, and that's the most healthy way of making sense of our life, our human experience. So if I was to ask you the following questions, think what your answers would be. So if I told you that I had a friend who is 6 feet 4 inches in height, would they be more likely to be male or female? Just answer in your head. Equally, if I told you I had a friend that is a ballerina, more likely to be male or female? If I told you I had a friend who can bench press 250 kilos, that's a lot. Do Do you think they'd be male or more likely to be female? If I told you, well, at this point you'd probably be thinking there's no way you've got this many friends, Paul. But if I told you I had another friend who liked Christian Louboutin shoes, and for those of you who want, lads, they're the ladies' shoes with the red soles. Dead expensive. Yeah, they're like Christian Louboutin shoes. Kind of gave away the answer there. So you kind of, to get your answer to the question, the friend who's 6'4", more likely to be male, because there are more males who are 6'4". Is it impossible that this could be a female? No. But there are few females who are 6'4" in height. Ballerinas, far more female ballerinas than there are males. I really try to think of an uber feminine example. Although, and of course, I know there are very successful male ballerinas. Yeah, more likely to be female, although not impossible that it could be a male. Although, picturing my mate, can't imagine any doing ballet. And equally the bench press, I don't even know what the female world record is. It might be, not even be that. And Christian Louboutin, I think they only do female shoes anyway. I think, I'm not an expert in women's shoes. Women's shoes. Okay, so we've looked at how you already think statistically, looked at where all these statistics come from is the next step. So where did they come from? Well, a long time ago. If we go back to Greek and Roman times, we had philosophers like Aristotle, Socrates, Plato, and they indulged in what's called a dialectic approach to philosophy, which is basically, you could say, having a chat. A dialectic approach, dialect, discussion between two people. It was basically an approach, a bit more than having a chat, of course, whereby two philosophers would discuss a certain hypothesis, a certain theory, and try and disprove it. And if they were unable to disprove it, then it must be true, must be considered truth. Now, back then, so if you were to take your dissertation and explain what you'd done, people back then would probably be pretty impressed, because obviously they didn't have the technology we have now to perform advanced statistical tests. In fact, yeah, the majority of investigation about the world was just done through visual observation, looking at the world around us and discussing what was seen. A pretty simple level. So that was the ancient Greek and kind of Roman era, where science was kind of reserved to more of a philosophical approach. There was Hippocrates was an early philosopher who did a lot of work in early medicine. And there was an emphasis at this time on rhetoric. Now, rhetoric is the ability of someone to speak in a persuasive manner. So, an example of poor rhetoric would be to adopt a monotone kind of tone to the voice, which never changed at all and was really hard to listen to, and never changed in that sort of manner. That would be the sign of someone who wouldn't be considered, well, it's an area of improvement for public speaking, let's say. Now, because we had this dialectic approach, there was a big emphasis on rhetoric and the ability to persuade just by being a good speaker, to convince people just through those skills. Now, in science today, to try and do that is considered a bit unethical. It's quite unethical, because science should be based not on someone's ability to communicate the scientific findings. It should be based solely on the findings themselves. Of course, being a researcher or a scientist today, it's considered an important skill to be able to communicate science well. But just to depend on this skill is not good practice today. Fast forward to medieval times, not a lot happened in science during this time because we were all busy pillaging, murdering. The Roman Empire collapsed. There was huge migration across Europe. When things kind of died down, there was the first universities, first one being in Bologna, was set up. And during all of this war and pillaging, a lot of really important books were burned, and so some important texts were saved, and they became, obviously due to their rarity, became even more important, and were translated into Latin and Greek, and obviously eventually English in modern day. And now we start to move toward a period where we take more of a scientific approach. So a move away from rhetoric and the ability to persuade through speech toward the ability to persuade through numbers and data. And we've got during this period the formation of laws like gravity from Sir Isaac Newton, and really the beginnings of modern of the beginnings of science as we know it. Whereas in modern science, in about the 1900s to the recent century, we've got huge advances. So more advances in the last 100 years than there have been since ancient Greek times. And this, with the technology revolution that we're in now, is just set to explode. Which is why I tell you, position yourself well and get ready for a world of opportunity, because things are changing rapidly. So in the last 50 years, or well, invention of electricity, that's a bit more than 50 years ago, obviously. But DNA, 1953, space travel, yeah, about 50 years ago. Internet, way less than 50 years, but look at the progress that's been made using technology. So that is my advice. Technology combined with expertise in an area that can solve problems is the future. Okay. Just look at, so I downloaded some software the other day to make better videos, to do a little bit of editing and that kind of thing. What's the first thing that you do to find out how to use it? You watch a YouTube video by somebody with a YouTube channel, and they make an income. It might be small, it might be quite considerable, but either way they make an income through that YouTube channel. And this is the first period of time where knowledge can be sold as a commodity, all via the internet. Have a look at a website like Skillshare. The more knowledge and the more of a specialist you are, then for the first time in history that can be converted directly into income. And that's why at the start of the module I try to explain how well positioned you are or how well positioned you could be if you just take this into account and really exploit it. So that's how we kind of, well, that's a background of statistics, but today, in modern day society, why use statistics just generally? Well, here's an example. So in 1957, a gentleman called James Vickery went around cinema theatres in America saying that if you pop up subliminal messages just for a flash, saying things like thirsty, drink Coca-Cola, then you could increase sales of Coca-Cola by roughly 57%. Now, this resulted in the banning of subliminal messages. When the message spread across the states, nobody chose to test whether Vickery's claims were true. And he actually later came out and said, sorry guys, I was just after a little bit of fame and fortune, which I've got now, thanks very much, but I lied. But because the messages spread like wildfire, some scientists did actually test out Vickery's theory and realized it was. But despite that, and despite some scientific evidence that shows subliminal messages have no efficacy whatsoever, they've still been banned by the United Nations. And if you read the actual document, it says they're considered a public health risk. Interesting. Now, there are ways of influencing people subconsciously, like in the way that hypnotist would. How do they do that? Well, if I give you a clue, somebody like a hypnotist would use techniques that depend on something called anchoring. So if you think of a certain smell, or if you imagine a certain smell, or a certain song might remind you of a certain person or a certain period of your life, good or bad, then yeah, the subconscious is a huge part of the mind. So yeah, that is true. But as for subliminal messages themselves, yeah, no scientific evidence to show that they work at all. So that's an example of why statistics are pretty important. So we've looked at how you already think statistically, really. So use your own kind of, depending on, what's the probability of this happening versus this. We've looked at where these statistics came from. Now we just need to look at statistics minus the stress. So just a guide, a surface level guide to stats and how you can use them or how you should use them. Now, for those of you who are probably in the minority, those of you who have been given data from your supervisor, you've got to bear in mind, first of all, and I would heed this advice quite carefully, you're kind of working back over to a certain extent, because if this is the research process, you're supposed to come up with a research question first and then do a literature search with a neutral perspective with no cognitive bias and come up with a hypothesis, a theory, and so on, and then collect your data. Whereas you're kind of going back over and then forwards again, if you get what I'm saying. So just be mindful of that. Make sure that because you've got your data, I would still, before you do any kind of analysis, before you perform your literature search, before you form any conclusions, and just so it's not influenced by knowing the outcome, because that's bad science at the end of the day. So this is just the research process, pretty straightforward. Have a look at what's been done, create a theory, and from that you've got your hypothesis and your null hypothesis. Identify your variables, collect your data, which has already been done, and then analyze it. So it's the designing and the analyzing parts that we'll sort of focus on. So let's say we wanted to pose a question: do physical activity levels during lockdown affect performance of undergraduate students during their dissertation? Well, to design our study, we go to the good old PCOS there. And so our population of interest, university students, so you could think, oh, okay, I'll recruit from the university. Nice and easy thing to do there. In terms of, well, there's no intervention, but the exposure we're interested in is physical activity. So send them, due to the unprecedented conditions at the moment, you can send them a physical activity questionnaire digitally, email it out, so they're not touching anything, contaminating anything, and then they could send it back. And then the outcome measures, so how you're going to express what you've measured. Well, physical activity, you could best express that in moderate to vigorous physical activity. You can get that from a questionnaire, so it's expressed in minutes per day. And you could measure the performance during the dissertation just using the grades, or if you were just looking at overall performance in third year, use the grades from semester 1, something like that. You get the idea. There's no comparison for this study design. And make sure you've got your measurement method nailed down. Why? This is a common question when you're doing your poster presentation. Okay, why did you choose to measure, this particular construct? So, for example, physical activity. Why did you choose moderate to vigorous physical activity? Or why, if you used steps, please don't. But if you did, that kind of thing, why did you use steps? So MVPA, as we call it, it's a type of physical activity that gives the greatest health benefits. Always understand why you make certain choices. Use a questionnaire. One questionnaire is called the International Physical Activity Questionnaire, the IPAC. And it's widely used, it's standardized across all studies, so the results can be compared quite easily. And the study design would just be cross-sectional, nice simple study design. That would be a fine dissertation. If it was done well, that would get decent marks. Of course, there's different ways to investigate one question. It depends on how advanced the literature is. You could just do something cross-sectional. You could, once you've got your data, you could split up students into those who meet physical activity guidelines and classify them as active, and then those who don't, you could classify them as maybe inactive or sedentary. Sedentary would be a lot less than not just not meeting activity guidelines. Or you could just compare and see if there's any relationships between the two, if you've got two continuous variables. Or an experiment, you would obviously have to create an intervention for that. And then you would have half on an exercise regime, and then you would have a control group. Obviously, you wouldn't be able to, you can't blind that kind of study because it's obvious whether you're in the exercise intervention or not. And then with longitudinal study designs, unless you started your dissertation in second year, forget about that, because over a longitudinal period you need several data collection points. So you recruit your sample and collect your data. Summarize the data, describe the sample. So statistics. Try and think of statistics as the way in which we can draw inferences or conclusions from the sample you've taken in relation to the population you're interested in. So if you're interested in people with type 2 diabetes, for argument's sake, then your sample should be really closely representative of that group of people, should be similar to them in all sort of characteristics. And that's really all statistics are. You've got two different types. You've got descriptive statistics, which allow you to describe the sample, and then inferential statistics, which link the sample and the population and allow you to draw whatever conclusions you want to draw. And the reason that's important is because if we've got, so at the moment there's about 65 million people in the UK. So that's a lot of people. And if you take a sample of 60 adults, then you've still got a population in the millions. Then it's statistics which allow you to make conclusions just from a really small proportion of what is at the end of the day a huge population. Again, if you were looking at amateur footballers, then how many amateur footballers are in the UK? And you might have a sample size of 20. It's statistics that allow you to make any links between the sample and the population. The first thing to do is just to look at the frequency with which your outcome measure occurs. So going back to our does physical activity affect your dissertation mark, then you could just split up the marks into percentages like this. This would be your 2-1s and your firsts and so on. And then you can see what the frequency is like and then the distribution. And the whole reason you do this is so you can get a measurement of central tendency, because what we're interested in is how the distribution or the dispersion of all the data points is around the measure of central tendency. So whether you use the mean, the median, or the mode, that's kind of secondary. So people get really interested in the mean, but that's secondary to looking at how the data is dispersed around the mean. Because within the population, you've got outliers. So that could be the smoker who lives to be in the 90s, even though they've smoked all their life, or the person who's totally immune to a certain disease. They would be people who, if they found their way into your sample, you're not necessarily interested in those people, because the smoker, this person for whatever reason might have some genetic marker that just confers a protection against lung cancer, and this person would be exactly the same. So these people, they've got a genetic advantage, and so you wouldn't necessarily be interested in helping those people because they don't need your help. So it's getting an idea of the variance around the mean or the mode or the median, which tells you whether if you've got outliers in there and how extreme those outliers are. And you look at the range, get the measure of central tendency, and the standard deviation, which is quite arbitrarily obtained. You just square all the deviations from the mean. So take the mean, and then every individual score, measure how far away from the mean it is. If you were to stop there, you could end up with a negative number. Okay? And so it all sounds pretty kind of made up on the spot, doesn't it? If you take the square root of whatever you have, then it means you'll always end up with a positive number. And so that's what we do to get the standard deviation. And that alone gives you a really good idea of what the dispersion of your data is around the mean, the mode, or the median. So that variation is important because that dispersal around the mean, that variation, could be due to the experiment. So in our example of physical activity levels and dissertation performance, any variation around the mean could be due to physical activity. So that's called systematic variation. Or non-systematic variation is where it's not caused by experimental factors. It's just due to chance or factors that we haven't measured. And that's a big difference in terms of any conclusions that you arrive at, and completely contributes to how you answer your original question. So we have summarized the data. Now, all we need to do is compare our samples or look for any relationships between the two and then report what we found. Straightforward. So you look at the frequency distribution, and most students pray on their knees that they have normally distributed data, because when you do your statistics module, it's always the parametric tests which are taught first. And when I teach statistics, I try and mix it all up a little bit, so it doesn't seem that when you're getting sort of fatigued toward the end of the module, the non-parametric tests, which I bet you couldn't name many, they tend to be less fresh in your mind. However, if you've got data that's normally distributed, the statistical tests that you use aren't as good. They're not as robust because they rely on a few assumptions. One assumption is that you've got a kind of a uniform relationship between the two variables that runs throughout the data, when that could quite easily not be the case. So your t-test is where you compare the difference between two groups. If the variables are from the same participants, it's a paired t-test. If they're not, it's an unpaired t-test. Straightforward. The R correlation value, or Pearson's R, by Carl Pearson, is the strength of association between two variables. Remember, correlation is not causation. And an ANOVA is just a t-test expanded, so you can include more than two groups. Now, if you wanted to predict performance in someone's dissertation, then let's say so what would you measure? Factors that would affect performance. You might measure how many lectures somebody had gone to. You might measure time spent studying, a few different things. time spent in the library, I was going to say, time spent engaging in the key texts. And using regression, you can enter those predictor variables or dependent variable and try and determine the dependent variable from one or more independent variables, so predictor variables. And you can work out a model to predict things based on that. But probably unlikely that any one of you will do multiple regression in that manner. Okay, when your data is not normally distributed, what happens then? Well, most students have come across just panic, because these tests are normally taught at the end of statistics modules and therefore are more easily forgotten. And they're also a lot simpler, but they're also far more effective. Now, when you don't have to rely on that assumption that the relationship between the two variables is the same throughout the data, then the tests that you use, what they do is they don't have to rely on a normal distribution, and so they just go from small to large and rank sections of data in accordance with their magnitude. So they rank data into kind of ordinal sections. So with a Mann-Whitney U test, the name might be less familiar than the old t-test, but this is just a t-test. Instead of using all of that continuous data, it's put the data into sort of ordinal ranks from small to large, and with that you get a far better, more accurate outcome. Same with Spearman's rho, which is just correlation for non-normally distributed data, or what you call non-parametric data. So it's same as the Pearson's correlation, but rho is just that symbol there. The data is not continuous, so it's rank ordered, just as we've got at the above here. And just how you've got your t-test and your ANOVA here, the Kruskal-Wallis test is just an ANOVA, but uses rank medians. So just finally, have you ever wondered where these statistics came from? I mean, they came from a small number of men, okay, a small number of statisticians, and they've remained quite unchanged over time. So one big name in the world of stats is Ronald Fisher, cleverest person ever. He did come up with the p-value, and said to have single-handedly created modern statistics. So he came up with the p-value, the probability value, which is used extensively in experiments. And we generally use a p-value of 5%, don't we? P less than 0.05 is statistically significant. Why is that? Well, I'll tell you why in a second. He came up with the t-test. Notice there's a slight pun there coming up. The f-test statistic, which comes from your ANOVA. If any of you can explain that just off the cuff, then I'd be really impressed. But the null hypothesis, which is not a kind of the be-all and end-all when we're using these statistics, and because quite often the p-value can be what if it's 0.051, I've seen dissertations where students totally reject their original hypothesis just because of that, and that's wrong. Why is it wrong? Well, let's take a look at how the p-value came around. So in the 1800s, there was a tea party going on in Cambridge, and this is true. And a lady walked past called Muriel Bristol, and she noticed, whilst there was lots of tea being consumed, that the waiter put tea in first, followed by the milk. Shock. Muriel didn't think that was the right way of making tea. She put the milk in first. And so a little bit of a debate ensued. And she said, well, I bet you I can tell the difference between tea made with the milk or the tea put in first. Now, who happened to be walking past at the time? Good old Ronald there. And you can even read about this in his 1935 book, The Design of Experiments. That's if you're really, really interested. So, obviously the null hypothesis was that she can't tell the difference between tea made with milk or tea first. But Fisher set up an experiment, so he gave her 8 cups. That is 4 cups with the milk first, then the tea, 1, 2, 3, 4, and then 4 cups with the tea first, and then the milk, 1, 2, 3, 4. And because he gave her 8 cups, because obviously she can't drink too much tea, I mean, she's only one person, there are 20 ways that he could arrange the cups, and therefore Muriel had a 1 in 20 chance of getting it right, which is quite small. It's only a 5% chance, 1 in 20, and wouldn't you know it, after using the 5% or 0.05 probability value to accept or reject the null hypothesis, this is where the p-value of 0.05 that many of you use as the golden something or other, I can't think of an example. So the message is, if your p-value is 0.051, which I remember when I was doing my PhD dissertation, and it was for one of the studies, don't sweat it. I still ended up accepting the hypothesis, and everything was fine. It's just statistics. They're just there to help. They're not the golden rule. Same with correlation. Carl Pearson, he came up with lots of statistics as well. Cleverest person ever. Well, I like correlation. You've got the R value, but how is it calculated? Well, you just plot, basically. If you put all of this into SPSS or your stats package, it's just plotted, and then a regression line is put through the middle, and then the distance or numerical distance of each individual data point from the regression line is just used to calculate your correlation coefficient. So if you really drill down to how these things came around, then some can be quite arbitrary, meaning, a little bit random. You would expect them to be slightly more robust in their design. And now you've got, how to interpret your R value, which you obviously know. So essential tips, now that you understand statistics are nothing to stress about or sweat about, make sure you still understand these things. And this is mainly a message for your poster presentation, okay? If you've used any statistics or you talk about any, understand the stats that you've used. And again, I'm just talking about on a surface level. You don't have to, drill down into the detail. More crucially, understand why you use them. There's nothing worse than knowing fine well that the reason a student's used certain statistics is because their supervisor told them to. And when you ask that question, why did you use repeated measures on over there? When you know that they've just been told to, you really feel, well, I do, I really feel for the student standing there sweating profusely. Understand what they show. So if you're running on over, you'll be asked to explain the F ratio and degrees of freedom and stuff. And these are all googly things, just Google them, or YouTube video, and or your degree notes. There's a thought. And make sure you use the correct tests, and you can explain and give a rationale as to why you've used those tests. So, just another statistics lecture. Not quite. We focused on getting each stage right, and we did that by looking at how you really already think statistically to a certain extent. We looked at the start of the session at heuristics, which are kind of human statistics based on our own experiences, our personal experiences, and how if you try and think more statistically about the world, you'll generally have a better experience of it. Second thing we did was look at where all these statistics came from. We went back in history a little bit and moved up until the present day, and then looked at the statistics that you could use that are available to you, but minus the stress. Just an overview, a guide, and mainly focusing on the things that you need to know, such as why you used a certain statistical test, what the results show, and those are the main things. So week number 5, I've given you some additional time away from the live lectures to get certain things sorted out, ethics, getting your first draft done, and any confusion around using data that's been given to you by your supervisor, get that sorted out, please.